Hello everyone, I'm Lee. In this video, we're going to continue to talk about the implementation for entry list by using linked list. We're going to add 3 add functions, and one will be add at the beginning, another one will be append, and another one will add sorted. So add sorted means add sorted by name. So we're not going to use any sorting algorithm to sort the existing list. Instead, we are going to build a sorted list, which means whenever we add something, we find the correct position, then insert that entry there. Okay, so let's take a look at the implementation file. So let's first take a look at the add at the beginning one. So add at the beginning one, we already discussed this one last week. So the reason we want to add at the beginning is it avoids traverse. That means the performance of this add at the beginning isn't related to the size of the list. So think about it. If you have a list of 1,000 nodes, traverse is going to cost you lots of CPU cycles. If you're going to have a 10 element list, it's a totally different story. So traverse means you have to visit the whole list or half of the list. So it depends on the size of the list. So let's see. Add at the beginning, we create the new node. Then we simply say new node next, assign head to it. So you insert it before the original head, then reset head to this new node, increment your size. This is the most efficient add for linear linked list because it avoids traversing the list. Now let's take a look at append. For append, let's see, we first need to go to the end of the list. Let's see, we create a new node and to hold the data. Then we do a testing. I say if not head, that means it's an empty list. So we don't need to traverse. We just say head equal to new node. Remember, every time when we create a new node, the next pointer is set to node. So that's right. And if it's not an empty list, we're going to use the pointer to traverse starting from the head. Then take a look at this one, while current next. So try to think about this. If I say while current, that will take me all the way to the end of the list. By end of the list, I mean it will take me all the way to the no pointer. That means I will pass the last node. But if I say while current next, that means when I get out of this loop, current is pointing to the last node of the list. Then you can set the next pointer of the last node of the list to new node. That's how you append it to the list. And this special case testing is extremely important. Imagine if you don't have this. We just go ahead and say set the current pointer to head and while current next. So that means the first time you come in, when you have an empty list, that means current is no. When you have an empty list, when you try to dereference a no pointer, your program crash right away. So every time, I hope you guys get into this habit. Every time when you type in this kind of thing, a pointer, then big arrow something, you need to ask yourself, is it possible for current to be no? If it can ever be no, that means this code will crash at some point. Okay, in this code, we are very confident current is not no, because if current no, that means head is no. And we already did the testing here. If head is no, we never enter the else part. So it's extremely important that you do the special case first. And also remember, when you type in this one, ask yourself, is this pointer be no sometimes? If it could be, then you should fix it. You should do the testing and handle the special case first. Okay, so that's the append function. You have to traverse to the end, and and append the node there. In our implementation, we only keep track of the head pointer. That means we only keep track of where is the first node. So it's inefficient to do the append. If you need to append a lot with your list, and you want to use linked list implementation, you should consider add another pointer called a tail pointer in your data member. Here, that means in your data member, you add another tail pointer to keep track of where is the last node. If you also keep track of where is the last node, then the append operation could be very efficient. You can just go, you have to traverse. That means it doesn't depend on the size of the list. The performance doesn't depend on the size of the list. So you can just go ahead and set tail next to the new node and do the special case testing too. So in your assignment, you're going to implement the appending function, but you're required to use the tail implementation. So you need to add a tail to the data member so that this append operation will be efficient, and it will be easier to implement as well. Okay, so that's the append operation. And the add sorted, like we talk about in the header file. Add sorted means every time when you add the item, you're going to add it at the correct position. In this case, we're going to sort the list by name. So we create a new node. Then we are trying to insert this node at the correct position based on name. This time we are going to use 2 pointers to traverse. You will see 2 pointers are more convenient when you try to remove something or insert something. Let's see. So one pointer I call it previous, and I started with no pointer, and another one I call it current. It started with head. They're going to traverse the whole list side by side. Let's see. While current, that means while I haven't hit the end of the list. So I'm going to inspect the data to see if I should insert before this current node. And if not, I'm going to update my traverse pointer. I'm going to update the previous pointer so that it points to current, and advance the current pointer to current next. So they're going side by side, so to the next node. And then come back to do the testing, say, am I hitting the end? If not, I'm going to see if I should insert the data before this current node. Assume after the comparison, I should insert the new node before current node. So you're going to say break and come out. How to insert the new node before current node? It will be new node next. Update new node next with current. That's how you put this one before current node. And another part, you need to link this node after the previous node. So how do we do that? We say previous next equal to new node. That's how do you link new node to the previous node. And that's how you link the new node to the current node. And again, there's a special case testing. We say if not previous, that means previous is equal to no. We never enter the loop. That means you're going to insert the node at the beginning. So that's easy. You just set head to new node. And we already linked new node next to current. And again, this is very important. Without this testing, when you do this, previous next, if previous is no, that means this code will crash. And previous could be no. If you never enter the loop, previous is no. So we do the testing here and we take care of it. And at this moment, we are confident previous can never be no. So this code can never crash. Again, whenever you type something like this, you should ask yourself, could previous be no at any point? If it does, then the code should be modified. You should do some protection here. Okay, so that's the add sorted one. And now my add function is just depends on which add do you want to use. You can invoke it. Thank you.